Yo, suppose the force of attraction between two body A and body B is given as 16 Newton. The first condition, if the mass of both is double and the distance remain the same, what will be the new force of attraction? Now, to solve that condition, the mass of both is doubled, the distance remain the same. What is the new force of attraction? Force of attraction is directly proportional to the product of the masses. Distance has a square. But in this condition, distance remain the same. So distance is out of the show. You are dealing directly with the force of attraction and the what? And the mass. And here, both mass is doubled. So force is directly proportional to the masses, mean that if the mass increase, the force will increase. So you have to multiply whatever force given to you with the results that you have here. And if the mass decrease, the force will decrease. It means you need to divide the force given to you with the result you have here. Now, mass is doubled. So force given to be 16 equal double the mass. Double the mass. Distance remain the same. So you have 2 times 2, which is 4. So the new force of attraction will now be 16 times 4, which is 64 Newton. That is the force you have. The second condition is if the distance is doubled and the mass remain the same, what is the new force of attraction? Distance is doubled, mass remain the same. What is the new force of attraction? If you look at the law, the force of attraction is inversely proportional to the square of the distance. Since mass is the same now, mass is out of the show. You are dealing directly with the force of attraction and what? And the distance separating the two bodies. Now, if the distance increase, then the force will reduce. And if the distance decrease, the force will do what? Will increase. Why? Because the two are inversely proportional to each other. Now, the distance is doubled. It means the force was given to be 16 equal 1 over double the distance. That is, you have square here. So you have 16 equal 1 over 4. So double the distance means you increase the distance. So increase in distance results to what? To a decrease in the force of attraction. So the new force of attraction will now be 16 divided by 4, which is equal to 4 Newton. The third condition now. Listen and listen good. The third condition says if the distance is reduced by 2 and the mass remain the same. Distance is reduced by 2 and the mass is what? Is remain the same. What is the new force of attraction? So force of attraction is inversely proportional to the square of the distance. Distance is reduced by half now, that is by 2. So you have force, which is 16 given, equal 1 over 1 over 2. That is it. You reduce it by 2. That is 1 over 1 over 2. That is half. So when you solve this problem you have here, you resolve this problem completely, you have 1 over 1 over 4. And 1 over 1 over 4 means 1 over 1 times 4 over 1. That's the meaning. So you have what we call 4. Everything here gives us 4. So you now have 16 equal 4. So the new force of attraction will just be 16 times 4, which is 64 Newton. That is the new force of attraction for the third condition. Then the next condition is if the mass of both is doubled and the distance is doubled, what is the new force of attraction? Double the mass of both, double the distance. What should be the force of attraction? Let's see. 16 equal double the mass, then double the what? Double the distance, 2 square. That is what you have. So you go and say 4, 2 times 2, 2 square is also 4. Everything is 1. It means the new force of attraction is also 16. No effect on the force. Just because you double the mass of both, So you now what? You double the distance. So there will be no effect on the force of attraction. So the next condition is if the mass of one is doubled and the distance is triple, what is the new force of attraction? The mass of one is doubled, the distance is tripled, what is the new force of attraction? So you have force of attraction is directly proportional to the mass and inverse to the square of the distance. 16 was given, mass of 1 is double, the other one will remain 1, then distance is triple, that is 3 square. You have 16 equal 2 over what? Over 9. 2 times 1, 2, 3 square is 9. So you have 2 over 9. So the new force of attraction is 16 times 2 divided by 9. So 16 times 2 will give us 32 divided by 9. That will give us 3.56 Newton. That is if mass of 1 is doubled and the distance is triple. The new force of attraction will be 3.56 Newton. So the next condition is where we are going to now. So the next condition is if the mass of both is triple and the distance is double, what is the new force of attraction? So triple the mass, double the distance. That is the condition. Triple the mass, double the distance. So you have 16 equal triple it, double distance. That is what you do. So you have 16 equal 9 over what? Over 4. So the new force of attraction, 16 and 9 directly proportional. 16 times 9 is what to do. Divided by what? Divided by 4 inversely. So this and this cancel. So you have 4 is 16. That is a 4. 4 times 9 will give us 36. So the new force of attraction is 36 Newton. So with that, we come to the end of the analysis. So I believe and I hope that with this explanation, we should be able to solve whatever condition given as regards to Newton's law of universal gravitation. So either you double the both mass or you double one of the masses, so you should be able to find your way out. Don't forget, so the force of attraction is directly proportional to the product of the masses and inversely to the square of the distance separating them. So it means that if the mass increases, the force will do what? Will increase. And if the mass decrease, the force will do what? Decrease. But for the distance, if distance increase, force decrease. And if distance decrease, force do what? Force increase.